Hey, what's up YouTube? It's been a while since I last released a blueprint system on my Patreon and made a breakdown video of it on my YouTube channel, so here it is. Today I'm going to talk about interaction systems. What's that, you may say? Well, it's an interesting topic because it's usually amongst the very first things that you try to do in blueprints, right? You may want to, say, have a light turn on when interacting with a light switch, as simple as that. So most beginner-friendly tutorials on the subject would probably suggest you to do some kind of trace of some sort, or maybe use a collision overlap event to detect that nearby light switch actor, then cast to that light switch blueprint, and call one of its functions directly in your pawn or character blueprint, right? Sounds familiar? Well, it works, but it's an extremely rigid solution. First, it's not scalable at all. What if you want to also interact with a chest, a button, a lever, and a long list of other blueprints? Then what if you want to have the player maintain the interaction input before that interaction is triggered? And what if you want to add conditions? What if you want to make that interaction unavailable for a while after being triggered? All that could be implemented in the light switch blueprint, right? But then again, it's not scalable. You'd have to duplicate that logic in your lever or button blueprint if it needed as well. And casting to other blueprints directly in your character blueprint has its own set of issues. Now, if all you're ever going to do in your game is turn on lights using light switches, then go ahead. By no means you should make your life complicated and do things the quote-unquote right way, if a simple solution is going to work just fine for your own limited use case. Most often though, you'll have tons of different interactions, so a sort of unified interaction system is most often required. And it's a great topic because it may also help new game developers get a grasp on why games are so complicated to create. Because again, it sounds simple, it's just an interaction, darn it. But when building such systems, you quickly realize that there's a ton of edge cases to solve and to account for, and things are never as easy as they look. So today I'm going to do a breakdown of an interaction system I just released on my Patreon as a tier 3 reward. Now, I feel like I tend to say this quite often in my videos, but I'll say it again. It's by no means perfect, it's by no means the only way to do an interaction system, and you might actually hate my approach, right? It's fine. I'm really just hoping to give you some ideas, some pointers that may help you build your own system and how a better solution can be built in Unreal Engine using blueprints. So I'll first start with a quick demonstration of what my system allows you to do, then I'll move on to how to actually use it in your own project, then I'll move on to the technical breakdown. Now that system is quite advanced, so beginners buckle up. It was quite a challenge to explain and I feel like I didn't do such a great job, but I did my best. Feel free to reach out to me in the comments below or on my Patreon if anything didn't make sense. Let's get started. Alright, here's a small demo map showcasing some interaction examples. First example, upon entering that sphere volume, a small widget is shown. It tells us what kind of action to perform, with which input, then the result to expect. Apparently we're going to trigger something, and what that something is. Looks like to be an interactive object. How creative of a description. And this is all customizable per interaction, and I'll show you how to do that in a minute. Okay, so let's do that. The interaction is triggered, cool. The second example is very similar, except that we are now asked to hold enter and the widget now shows a circular progress bar. Do that and interaction is triggered once progress is completed, cool. Now let's take just a minute here because there's already some edge cases to account for, and this is why I said earlier that nothing in game dev is as easy as it looks. Obviously that interaction should be cancelled upon releasing the enter key before it's completed, right? But what happens if we hold that input and go out of range? And what if I go back in that interaction volume, right? And what if that object gets removed from the game for any reason while I'm holding that input and interaction is in progress? It's not a huge deal to solve, but it's exactly that kind of edge case that creeps in and makes building such unified system a challenge the more features you add. Anyway, moving on, third example, this object goes to sleep for 2 seconds after an interaction. And here's yet another edge case, which is way too often not even accounted for in many games. You know how annoying that is when you need to get out of some kind of trigger volume to have an interaction refreshed, right? Here I may stay within that volume and the interaction is automatically available again. Next example is a combination of the two previous examples, meaning I have to hold an input to trigger the interaction and then the actor goes to sleep for a while. Next example showcases priority system, which offers a stable and consistent solution in case multiple interactions are available. So here the largest sphere represents the interaction having the lowest priority, see? And the smaller sphere represents the interaction having the highest priority. And so as soon as I enter that second volume, only that interaction can now be triggered. Next example, same thing, but the highest priority interaction makes that actor sleep for a while, and that allows me to trigger the low priority interaction for that time. Last example showcases a simple condition, so that actor here isn't interactive yet, because it asks for that lever to be turned on. And that lever can only be turned on once, and as soon as I do that, that actor can now be interacted with. And all that is actor agnostic, using components and blueprint interfaces, meaning that you can implement this on a button, on a light switch, on a character, whatever, right? There's no cast to hard-coded classes involved. There's also close to no extra blueprint logic added here, right? It's all handled by the system. Cool, now let's dive a bit deeper and see how to use that system. Alright, so the system is pretty much built around 3 components. There's 2 actor components, one meant to be added to your pawn or character, which I'll refer to as the pawn component from now on. One meant to be added to any actor that you want to interact with, which I'll refer to as the actor component from now on. And there's one blueprint interface that you may want to add to any actor that you want to interact with, but it's not a requirement. Okay, so let's investigate that blueprint here. It has a cube mesh for its look and a sphere volume. That sphere volume is configured to generate an overlap event with your pawn, right? So you must make sure to have that correctly set up. That same sphere volume is automatically going to be picked up by this component using a tag. By default it's that one, but you can change it here if you want to. This blueprint also implements that blueprint interface I just mentioned. Again, it's not a requirement, but it offers a single function that you can override to control if that actor can be interacted with based on any logic. Let's pretend that actor shouldn't be interacted with anymore, so I'm going to override that function, set it to false, then check in-game, and it's indeed the case. Cool. And actually, this is how the condition on that actor here was set up. It checks if that lever blueprint it references is turned on, and that's what's driving its ability to be interacted with. That lever, by the way, gets turned on when the interaction is processed, and that event comes from the actor component. It has quite a few events you can listen to implement any kind of logic per actor, right? It's quite self-explanatory. Most useful one is obviously that one, which fires whenever an interaction is successfully triggered by the system. Moving on, that pawn component have a few settings you can tweak. For how long should the actor go to sleep after a successful interaction, if it should at all. For how long should the input be held to trigger an interaction, if any duration. The interaction priority. A text to describe what kind of object the player is meant to interact with. This can be later updated at game time by calling these components set interaction description function. So in case the interaction should normally say, hey, press enter to dialogue with soldier, you may have a dynamic context, meaning, I don't know, check if that soldier's health is low enough after an in-game event, to instead say press enter to dialogue with wounded soldier, right? Same idea here, this is used to describe what kind of action to expect. Are we meant to turn a lever, to press a button, to dialogue with someone? You get the idea. That also can be changed at runtime with that set interaction action function. Same thing for the delay and sleep duration, by the way. Also, pro tip, if a blueprint is properly built, its developer should have made proper use of access specifiers to have private, protected and public functions. Meaning that when you use a system a developer has built, you should only really pay attention to public functions at first, unless you want to dig in and try to understand how it's been built. Those public functions are meant to be called by end users to, well, actually make use of that system. It's like the public API, right? Protected functions are usually meant to be overridden in child blueprints, and private functions are used to build the internal logic of the system. Back to our actor component, note that you can edit those settings here, but also per instance directly in the level, right? That way you don't have to create a unique blueprint for each unique interaction description or something. Moving on, there's a couple of extra settings in the pawn component you may want to look at. Recycle widget is going to keep that interaction widget in memory and reuse it for all interactions. It's going to cost a tiny bit of memory because Unreal Engine will never garbage collect that widget object, so that's something to keep in mind, although it shouldn't really be a concern. Releasing that resource from memory and creating a new widget every time an interaction is available isn't ideal either. It's not like it's free, so as usual it's a trade-off. I'd argue it's best to keep in memory and recycle it, but you might disagree. Anyway, here there are a few settings to control that radial progress bar look. And there are also a couple of public functions you may want to look at, mainly those update widget text functions to further customize that interaction widget text box. And voila, I believe it's quite an elegant solution, both in terms of user experience and implementation. Again, it's not perfect, but I would argue it's a decent starting point if you're looking for a first interaction system for your own game. It's also a good educational project because everything is greatly documented. Functions and variables are all described in details, and blueprints are all quite clean. So I guess now is the time to dive a little bit deeper, to get technical and see how it's built, right? Buckle up and let's go. Alright, so I suppose I'm going to start with that actor component, the one meant to be added to any actor you may want to interact with. First things first, upon begin play, it calls this register trigger volume function. This function looks for a primitive having that volume tag you need to add to a sphere volume or any kind of trigger volume, right? And binds that volume's on-component begin and on-component end overlap events to two other functions. Also, if that component is destroyed for any reason, I keep things clean and make sure to unbind those same events. I also call that event dispatcher because why not? Event dispatcher in components are awesome to work with. You may create one, call it somewhere in that component blueprint, and then all you have to do in the blueprint owning that component is to right click on it, and then you can super easily bind that event and implement whatever logic you like on the actor side, so that every time that is called in the component, this is as well in that actor. And that's precisely what happens with the function that I bound to that volume's onBegin overlap event. Upon overlap, it double checks that the object responsible for that overlap event is indeed the player's pawn. Then I get its interaction component, the one you're meant to add to your pawn or character blueprint, right? Next I just forward self, so this actor component, to that pawn component, which will then add it onto a stack if it's not already on it. That stack is to keep track of all interactions currently available in case there's multiple ones on our pawn at the same time and I have to find the most relevant one to trigger. Here I bind some of our functions to that component's events I'm interested in, like if an actor component calls, let's say, that event dispatcher, this pawn component is aware of it. Okay, remember this function is triggered because our pawn has entered the volume of an interactive actor, right? So at this point I probably want to hint at the player that an interaction is available nearby. So this function loops through all interaction components on the stack and finds the first available one having the highest priority. Note that for now I chose to introduce a limitation for simplicity's sake, meaning that I can only trigger one interaction at a time. I cannot interact with X items all at once, but maybe I'll revisit this at one point. Anyway, to find that most relevant interaction component, that blueprint interface function is called on each component's owner, which is that function you can override per actor to decide of that interaction's availability, remember? If that actor doesn't implement that interface though, then I assume interaction is available, thus why implementing that interface isn't a requirement. Anyway, during the loop I also filter by priority to get the highest one, and the component I end up with is then sent to that update interaction widget function. I then get the widget actor, which is a very simple blueprint that just owns a widget component, because all of our logic happens within components, and components cannot own components, right? Thus why relying on an external actor to have access to one. So if that actor doesn't exist yet, I spawn it and keep a reference to it for future calls. It's then moved to the location of that actor or pawn may interact with and made visible. Then I get its actual widget component user widget to first update its text box and then figure out if I need to display that radial progress bar based on the interaction delay. Now at that point we have an interaction widget visible as soon as an interaction is available and it displays the correct information. What's next probably happens in the pawn blueprint. Now, such interaction system can often be quite closely tied to an input system, and that can make the complexity of the whole thing skyrocket, and that was definitely out of scope of this interaction system. You might need to detect if the player switches between keyboard and gamepad, support multiple gamepads, Xbox, PlayStation, support multiple interaction buttons, remap interaction buttons in an option menu, right? So I definitely didn't want to dive into all that. So the approach I chose was to let you do your own thing and figure out for yourself which input should be used to interact with items in your game. Here I hard-coded interactions to be triggered on the enter key. Then all you need to do is to call that component's press and release action functions. And then you can customize the interaction widget to display that key or button to use, either using plain text or an image. Here, for instance, I notified the system to display that enter key as a plain text, but you can use an image as well using an ID from a rich image data table, since that text widget is a rich text, okay? Feel free to take a look at that documentation page if you're unfamiliar with rich text. Okay, so at that point the player knows he can interact with something nearby. So let's assume he eventually presses the interaction button. A message is sent to the pawn component, it goes through its stack of actor components one more time, just to be sure to have the highest priority interaction actor component at that time, and if any, it calls that component's start interaction function. This in turn checks if that interaction is meant to have any delay. If so, then a timer is started to delay a call to that process interaction function and return delay true, else it's called immediately and return false. In that function, if the interaction is meant to sleep, a timer is started for that sleep duration. Then that event dispatcher is called, which is one that this component's owner may listen to implement any logic desired upon interaction, right? The timer will then eventually trigger to simply call this event dispatcher, one that remembers the pawn component listened to, so that it may know whenever an interaction that was asleep is now available again. Cool, now that all happened because we assumed that the interaction wasn't delayed, meaning the input to trigger that interaction wasn't meant to be held. Let's now assume it is, and player should maintain the input for a certain duration before that interaction triggers. So that start interaction function, instead of calling that function right away, starts a timer to delay it and return delay true, right? This lets the pawn component know that this interaction is indeed delayed, and so it caches that component to keep track of it and listen to its delayed interaction process event, which will eventually fire. Then here, regardless of that interaction being delayed or not, it updates its interaction widget. We might need to activate the radial progress bar and all that. Now, once the pawn component receives a message from that actor component stating that it did eventually trigger, it unbinds that event, clears its reference to that actor component, and updates its interaction widget once more. Interaction may now be asleep and we might need to hide the widget and that kind of thing. In case the player releases interaction input, the pawn component first checks if it kept track of any delayed interaction component. If so, it means it was in progress but didn't have the chance to trigger yet, and so the pawn component calls that end interaction function on that actor component, unbinds its event, clears its reference to it, and updates its widget once more. Now there's one last piece of the puzzle missing, which is when the pawn exits the interaction volume. Remember, the actor component has one function bound to the onBegin overlap event of its owner sphere volume, right? So that it may know if the player pawn is within interaction range. But it also has one function bound to that same volume's end overlap event. Same principle, get the overlapping actor, check if that's indeed our pawn, get its interaction component, and call that remove interaction component function. This in turn checks if that component is on the stack to begin with. It should at that point, but just to be sure. If so, make sure to unbind any events we may listen to. Then if there's no interaction at all anymore on the stack, meaning the pawn is apparently not overlapping any interaction volume anymore, clear the widget, else update it with the newest highest priority interaction. And finally, we must check if the interaction being removed, the one our pawn is no longer in range with, is the one that got delayed, if we had any. If so, its progress must be terminated right now, and to do that we simply mimic the player having released the interaction input. And that's pretty much it. Anyone still with me? Yeah, okay, cool. So, you see that system, despite just being a simple interaction system, has quite a few moving parts to support delay, sleep, availability, widget, all using an efficient event-driven architecture and no ticking part. and it involves pretty much most of what you can do with blueprints, meaning there's timers, there's event dispatchers, there's blueprint interfaces, there's components dialoguing with each other, so it's quite complex. So let's just take a step back for a second. Initially, we just wanted to make our pawn interact with an actor, whatever it may be, right? The naive approach would be to get a reference to that actor in some way, cast to whatever class we need to dialogue with, and simply call that class functions directly, like hey, do this or do that. But it has many issues, mainly it's not scalable, and casting to classes involves hard references, and that has issues on its own. I've actually covered that topic in details in my minimap breakdown video, so make sure to give that a watch. Anyway, we could just use a blueprint interface to send a message to that actor without any cast. Yep, cool. But then it's quite limited still and won't be enough if we want to implement sleep and delay mechanisms, automatically handle a widget and so on. So here's how my system deals with all that. The player has a component and the actor it may need to interact with also has its own component. That actor should also have some kind of volume configured to generate overlap events with our pawn. The actor component gets its owner and looks for its primitive components to get one having a specific tag and bind its overlap events. That way, when our pawn overlaps with that actor's volume, its own begin overlap event is triggered, which is forwarded to its component as well, and the pawn reference is sent along the way. At that point, that actor component can use that pawn reference to get its component and send a message like, hey, interaction is available. The pawn component then adds that actor component onto a stack, essentially creating a way to communicate with that actor component later on. At that point, we want to display a widget to the player, so the pawn component creates an actor which owns a widget component, which has a reference to a user widget we can access. Now, to update that user widget and have it display the relevant information, the pawn component must already try and get the most relevant available interaction to get its information. To do that, that stack of actor components is looped through. Each time, it queries that component's priority setting and also checks if its owner is available for an interaction via an interface it may implement, so that availability can be programmed per actor. Once the most relevant interaction is found, the pawn component gets its data and updates the widget. Now, at that point, the player may press the interaction input, and if he does, a message is sent to the pawn component, and because that action happens at a later time, it goes through the stack once more to find the most relevant actor component and send it a trigger signal. That actor component may then process that signal and reply in two ways. Either it says, hey, that interaction was triggered without any delay, it's cool, or it says, hey, that interaction needs some time to be processed, it's delayed. If it's the latter, the pawn component listens to an event that actor component will trigger once that delay has passed. And then that actor component triggers an event dispatcher that his owning actor may listen to finally deliver the interaction message and do something with it. If it's a door, open it, a lever, turn it, a button, push it, whatever. And that's one possible way of building a unified interaction system. Voila, I hope you found that video useful and that it helped you in your own quest of building such system. Let me know what you thought of that diagram explanation, by the way. Did it help? Was it redundant? It's a new blueprint system I just built to hopefully make those very technical breakdowns more comprehensible. So yeah, let me know. Also, let me know if you'd like to have a demo of that diagram system as well. If you're interested in that one system I just showcased, well, it's available as a tier 3 reward on my Patreon, along many other Unreal Engine projects and assets. Thanks for watching, thanks for your support, thanks to all my Patreon supporters. Consider leaving a like and subscribing to the channel if you like the content. I'll see you in the next video, take care of yourself, bye bye!